You know, have you ever looked up at the sun and just wondered, how does it produce that incredible amount of energy day in and day out? Well, it's all powered by nuclear fusion. And for decades, scientists have been on this amazing quest to replicate that exact process, the power of a star, right here on Earth. So let's dive in and see how this could solve some of our biggest challenges. To really get why this quest is so incredibly important, you first have to look at where we are right now. And honestly, the picture is pretty stark. A staggering 80% of all the world's energy still comes from burning fossil fuels. We're talking coal, oil, and natural gas. Our entire modern world is built on them. And this analogy, it just perfectly nails the problem, doesn't it? By burning all those fuels, we're pumping billions of tons of carbon dioxide into the atmosphere, trapping heat. And it's not just about the climate, it's also about the gunk that's fouling up the air in our cities. We're basically filling our own home with exhaust fumes. So, yeah, this brings us to the core problem that we absolutely have to solve, our global energy crisis. And it's really a two-part crisis. We have a skyrocketing demand for more and more power, and a supply that's just damaging and unsustainable. Okay, so what about the renewables we already have, like solar and wind? Look, they are fantastic, and we absolutely need them. But they have one major built-in limitation. They're intermittent. Think of them like a really powerful flashlight. It's amazing, but it only works when the sun is out or the wind is blowing. Fusion, on the other hand, is the ultimate goal. A massive, clean generator that's always on, 24/7, no matter what the weather is doing. All right, so we've laid out the problem. Now let's get to the really exciting part, the solution. We're literally talking about bringing the power source of the stars down to Earth and building a miniature sun in a bottle. You'll hear people call fusion the holy grail of energy, and it's for three huge reasons. First, the fuel comes from water and lithium, stuff that's abundant all over the planet. Second, it's just inherently safe. There is zero chance of a meltdown. If something goes wrong, the whole reaction just fizzles out. And third, the main thing it produces is helium. You know, the harmless gas we use for party balloons. And if you want your mind blown, get this. The amount of deuterium, that's a key fusion fuel, that you can find in a single glass of regular water has the energy equivalent of an entire rail car packed with coal. The amount of power locked away in there is just, it's almost hard to believe. So that's the what and the why. Now let's get into the how. How in the world do you actually do this? We're going to break down the science of bottling a star into a few simple ideas. This is it. This is the big question that scientists have been working on for more than 70 years. How do you do it? Well, to make fusion happen, you need to create and control three totally extreme conditions: unbelievable heat, massive pressure, and a way to hold it all together. It all starts with making something called a plasma. Just imagine taking a gas and heating it up to an absolutely insane temperature. We're talking 10 times hotter than the very center of the sun. At that temperature, electrons literally get ripped away from their atoms, creating this electrically charged, super hot soup. That soup, that's plasma. And it's the only place on Earth where fusion can happen. So what's the gas we're heating up? It's two special versions or isotopes of hydrogen. The first one is deuterium, and you can find that in any seawater. The second is tritium, and this is the really clever part. You can actually make tritium from the common element lithium right inside the reactor as it runs. And here is where the magic happens. You take that plasma made of deuterium and tritium, and you squeeze it with so much force that the atoms can't help but fuse together. What you get out is a harmless helium atom and one single super high energy neutron. That neutron goes flying off, carrying a massive amount of energy with it. And that energy is what we're after. But wait a second, how do you hold on to something that's 150 million degrees high? I mean, no material on Earth could possibly touch it, right? Well, the solution is just beautiful. Magnetic confinement. And it works in 3 steps. 1, you heat the fuel into a plasma. 2, you use unbelievably powerful magnets to squeeze and contain it. And 3, you capture the heat from those neutrons to make steam and turn a turbine just like any other power plant. There's this fantastic analogy for how these donut-shaped reactors, which are called tokamaks, actually work. Okay, so imagine the reactor is a big jelly donut. The jelly in the middle, that's our super hot plasma. The powerful magnetic fields act like a twisting, invisible cage, like a magnetic rubber band that wraps all around it, squeezing that plasma so it just floats safely in the middle, never, ever touching the walls. Now, this is a question that comes up all the time, and it's a really important one to clear up. Because while they both involve the nucleus of an atom, fusion and the fission we use in today's nuclear plants are fundamentally different. I mean, they're practically polar opposites.
Let's just put them side by side because the differences are night and day. Fission, which is our current nuclear tech, works by splitting heavy, unstable atoms like uranium apart. Fusion does the exact opposite. It merges light, abundant atoms like hydrogen together. Fission needs mined uranium and creates nasty, long-lived radioactive waste. Fusion's fuel comes from seawater, and its only waste product is harmless helium. And the biggest difference, fusion is inherently safe. There's no chain reaction or runaway. Fission plants need huge, complex safety systems to prevent that.
Okay, so if fusion is so perfect, why don't we have it yet? For decades, it's been the butt of a joke. It's always 30 years away. But things are changing. We're shifting from a question of pure science to a challenge of pure engineering, and the timeline is speeding up, fast. That old joke is finally getting retired. A massive breakthrough happened in 2022 that really kicked off a new era. Right now, the world's biggest experimental reactor, called ITER, is being built in France to prove this technology can work on an industrial scale. And even more exciting, a whole wave of private companies are now in a race to build the first commercial plants, and they're targeting the 2030s. And that 2022 breakthrough, wow, it was a monumental moment for science. For the first time ever, at the National Ignition Facility in the US, a fusion reaction achieved what's called net energy gain. It means they got more energy out of the reaction than they had to put in to get it started. Now, it was only for a split second, but it proved once and for all that the basic science works. It's possible. So, with the science now officially proven, we can start to really imagine what a world powered by this technology would actually look like. And it's pretty incredible.
The most immediate and massive impact, of course, would be on our climate. Unlike fossil fuels, fusion isn't low carbon. It is a true zero-carbon energy source. Getting this technology widespread would be the single most powerful thing we could do to stabilize the climate, period.
And the transformation goes so much further than just carbon emissions. Because the fuel is basically everywhere, any country could become energy independent. Think about how that would change global politics. It would mean clean air in our cities, better public health, and the birth of entirely new high-tech industries and jobs. It would be a complete game changer for human civilization. And that brings us to right now, today. The question isn't if fusion is possible anymore. We know it is. The question is when we will solve the remaining engineering challenges to make it cheap and reliable. The mission has moved out of the physics lab and into the workshop. It's a huge long-term investment, for sure, but it's an investment that could power a clean, prosperous, and stable future for every single one of us. The science is proven. The engineering is next. The choice to build that future is ours.